Okay, let's do office hours. Problem solving. General camaraderie.
General camaraderie?
Yeah.
I don't know if that's very.
Guys. Yeah, that's a great question. So, so closure properties. So it makes more sense when we talk about something when we go a little forward called the decidable and recognizable languages. But let's do closure properties of regular and context free. So let's make a chart. So let's see. So let's put regular there and CFL there. So let's put union. Intersect, complement, concat, star. So these are the 5 fundamental ones. So what do we know for the regular languages? Yes, it's all of them. Yeah. Union and intersect are product construction. Complement just flip the final and non-final states of a DFA. Concat, we used NFAs for that, and NFAs are equivalent. And star, we also used NFAs. What about for CFLs? So we saw union, yep. What else did we see? Concat and star, good. Intersect and complement? No. So here's an interesting one. What about intersect with regular languages? So is a context-free language intersect a regular language necessarily context-free?
Oh, I see. CFL intersect regular.
And the answer turns out to be yes. And that's in problem set 2. Partly in problem set 2. So the problem set 2 asks for doing it with a CFG only, but if you do it with a PDA, it's a lot easier. And the 2 important words are product construction. So you do exactly the same product construction with a PDA and a DFA, except on the transitions, what do you do with the stack? Well, what do? You just see what the PDA would have done. Because is a DFA just like a PDA that ignores the stack? Yeah. So whatever the PDA would have done is just whatever you do on the stack in the product now PDA. And then if you work through the details, it actually is the correct PDA. Let's record it. So, yeah. So the idea is intersect a PDA with a DFA, then do exactly the same product construction as before, except the only difference now is for the stack component in the product PDA now. Well, since the DFA has no stack at all, doesn't do anything with the stack, the only thing that the now product DFA needs to do with the stack is just what the original PDA would have done. In fact, this is exercise, I believe, 2.18 in the textbook, and it has a sample solution in there. Okay. 2.18, I believe. I've talked about that problem so many times, I know the actual problem number. Other questions? So does that answer the closure properties question?
I was writing it all down.
All right. Yeah.
So what would the closure properties for non-regular?
Oh, great question. So non-regular. So these are not the same thing as, so I'll put down union, intersect, complement, concat, and star. Okay? So these are not the same thing as CFLs. And it actually turned out that the closure properties are different. So if I have two non-regular languages, is their union necessarily not regular? Or could it be regular? Yeah. Any example? So it'll actually turn out, do complement first. Are non-regular languages closed under complement?
Yes.
Yes. What's the proof? Exactly. If a non-regular language's complement were regular, then we know regular languages are closed under complement, but that's the original language. But we assumed it's not regular. So they are closed under complement because the regular languages are. So is the union of two non-regular languages non-regular or not?
Yes. Closed under union for regular.
That's not necessarily true. So let's let L be any non-regular language. What is L union the complement of L? What is any language union with its complement? Yeah, the entire thing, which is regular, which is called sigma star. Thank you. But that guy's regular. L is not regular. Is L bar not regular? Yeah, because non-regular languages are closed under complement. So we don't get closure under union, sadly. What about intersect? Take the same two examples. What does any language intersect its complement? Nothing, which is it regular?
Yes.
Yeah. So we get no closure under intersect either. So these last two, I actually don't have any examples offhand, but I believe that they're both closed under concat and star. No, they're not closed. Sorry. But the examples are not that easy. The idea is for concatenation, you ensure that they contain enough strings so that when you concatenate them together, you'll have a chain of unions, because you'll be doing unions in here, such that their union contains sigma star. And then therefore it's everything. But I don't have any examples offhand. I can look it up when I get back. And star will work almost the same because it's just repeated concatenation. Yeah.
So to take a step back,
Uh-huh.
when you say that there is intersection between context-free languages and regular languages, what's the result? Is it just regular?
It must be context free. It may not be regular, but it has to be context free.
Okay.
Yeah. Because every regular language is context free, then it may be regular, but every regular language is context free. I can only guarantee it's context free. Yeah. Other questions?
For question 6 in the problem set 2.
Problem set 2, okay.
Yeah. What is the acceptable solution to that? Do you want us to
What was the problem again?
we have to prove the way you just said that intersection.
Yeah. So if you describe, you're given an arbitrary CFG and let's say an arbitrary DFA, could you produce a CFG for the intersection of their languages? And so if you can, then and show that it's correct, then that's all you need to do.
So give an example of anyone?
Well, if I give an example, that'll give the strategy.
No, I'm saying, do I give an example of anyone?
No, examples don't prove anything. If you need to consider an arbitrary CFG with the 4 parts and an arbitrary DFA, then you'll describe a process of making a CFG based off of those two. Okay? And 2 words, product construction will help you here. But now you got to work with a CFG instead of a PDA. But it's almost like the product construction. Yeah.
I'm having trouble problem set. I want to do tomorrow. And,
What did I say?
What was that?
What did I say about the due date? Let's do Thursday.
You moved it?
Mhm.
You moved it?
At the beginning of class.
Oh, wow. I did not catch that.
Mhm.
Okay, I can't know.
So do you want to re-ask your question?
Yeah, I still want to ask you. I'm having trouble deriving for question 1
Mhm.
regular expression.
Mhm.
I don't know if there's like a different example you can do that's not that exact question. Is that
So the idea is, well, let's consider this. So is this a valid regular expression according to the problem set definition?
No.
No, why not?
Neither.
I need the concatenation operator in between, or a union operator, but there must be some operator in between. So what you need to figure out is, between any individual character, there must be either a concatenation or a union operator, all the way through. Then that handles without brackets. Well, let's say that R prime handles all these. What can go in between any pair of brackets? Any regular expression without brackets. Do we have a regular expression without brackets? Yeah, it's called? Don't make me fall. It's called what? Someone shout it.
There's R prime up there.
R prime, thank you. R prime generates everything that could appear between any pair of brackets. Well, what could appear after this? Well, R prime, but what has to go there? An operator, a concatenation, or a union operator? Does that make sense? How many of this can I do? How many times can I repeat this process? As many times as I like. How do I write 0 or more times? Star. Okay. Other questions? Yeah. I can't hear you, sorry. Oh, I'm not sure what the question is. I'm saying if you have, yeah, you don't have to have brackets, but if you do have a left one, you have to have a matching right one, always, right? And so, yeah, if you happen to generate a left bracket, you have to have a matching right bracket with it, okay?
I'm gonna ask about 4. I know you answered, and I don't think.
I don't remember what 4 was.
Oh, for the regular or not.
Yeah. Mhm.
Okay, so if for, I know if it's the entire alphabet, whatever sigma star, it's regular, right? We know that.
Yeah.
But if, doesn't it have to be regular for, I mean, if we make one be an empty string, one element be an empty string, how is it regular for all W in the alphabet?
So give me an example of one of the problems.
WXW, WX are in 0,
Mhm. Yep.
1, one
Mhm.
star.
And it's no condition on the length, right?
There's no condition on the length
Mhm.
whatsoever.
Yep.
So we set it to be empty string, W to be empty string.
Mhm.
Therefore, X is
Can be
single
everything.
stars, right?
Yep. So what does the language have to contain?
It has to contain a regular language
No,
as X,
no,
right?
it does, but what is it? What is it really? What does it contain every string?
Yes.
So what does the language have to be?
Oh, shh. I just needed to talk. I should have talked it out. Okay, that makes sense. I got it.
It's thinking about if you set one of the parts to
And
be
it
a
can't
certain.
be more than everything. That's the thing.
Yeah.
It can't be more than everything.
Exactly.
Okay, that was the
Okay. Other questions?
Okay.
The regular languages in part one, do we have brackets next to each other? Is that very matched?
You mean like a
Nested?
no? There's no nested, but are you asking like right next to left?
I was asking nested, but that would be.
Yeah. So the question says without nested.
Okay.
If I allow nested, it turns out to be not regular, as in question 4.
But we could have like nothing in between them, right? So
No,
it's just left
no.
followed by right.
You have to have some operator, union, or concatenation between every pair. Yes.
No, what I'm asking is could there just be nothing in between left and right? Brackets.
Oh, great question. We're going to say there has to be something. Either 0, 1, empty string, or empty set. At least one thing. Yeah.
Or those are the characters.
Yeah. One of the 0, 1 empty set characters. Yes. Yeah.
Do you have concatenation between the bracket and the 0 or 1?
Yes. Yeah. Yeah. So if it happened to be a 0 right after, you have to put a concatenation there.
Even and inside as well.
What do you mean inside?
Like
You mean like-
bracket 0 would be bracket concatenation.
Oh, no, not there.
Okay.
Oh, that's a good question.
Yeah. But please don't change that answer.
Yeah.
It should
But the-
technically have to.
But the concatenation is along the single
it follows-
characters, not with respect to.
I'll
the
say
word.
yes, but I'll allow both solutions.
Yeah, if it follows that, it has to follow the other way around.
Also, the problem does say state or something.
Yeah, it says state your assumption. So if you assume that you don't put an operator there, that's fine. Yeah, because it didn't say that there had to be in the problem statement. Other questions? Yeah.
Could we review the steps of converting from one type of machine to another? Because I often get those mixed up.
Okay. So what are the conversions that we've seen so far? Well, product construction was for. Well, actually, let's just look at all the constructions, I guess. Product construction, what did that do? Or show, at least. Yeah, regular languages is regular, yeah. So, so closure, under, union, intersect, and a bunch of others for regular languages. So then we saw another one, power set. What was that one about? Yeah, that was NFA to DFA. What were some of the other, we didn't name every single construction, but what were some of the other constructions that we've seen? Yeah, so that was further along the line, so I'll put that down here. And of course, we saw PDA to CFG as well today. What were some of the other ones that we've seen before?
NFA to CFG.
To not quite as, well, it already is a CFG, but what else?
Regular grammar.
To a regular grammar, yes. But since all regular grammars are already context-free grammars, that's true as well. And then we saw reg grammar the other way. What were some of the other ones we saw? There were two more, I think. What was the fourth equivalence for regular languages? Yeah, so that was used for showing what? Conversion between. NFA to regular expression. So GNFA method was NFA to Regex. And we didn't name this one, but we did Regex to NFA as well. Yeah, so those are I think those are all the constructions that we've seen in terms of converting between things and other things. Other questions?
Could you explain before one, how to do it, like, how to get started, because I'm not sure.
I've done it like 5 times. The idea is, well, you use that starter regular expression I give you, 0, 1, empty string, empty set. Well, so ignore brackets for a second. If you don't have any brackets, then between every character is what? Union or concatenation operator. And I can repeat that as many times as I like. Okay? Then, what can appear between any pair of brackets? Well, one of those. The regular expression that you just made for any number of concatenations and unions without brackets. That can appear within brackets. And then you can repeat that as many times as you want. Okay? It's just building up from smaller to bigger regex.
You can only have those alphabets that we
Yeah. But you can change the name of them, but you have to work with that alphabet. Unless you do the partial credit thing, which is ignore brackets altogether. Yeah.
So I was also a little bit confused about the star,
Mhm.
like the alphabet star.
Mhm.
If I were just to write R star, like the alphabet star, would that be valid or not? Like a valid regex?
It depends. If you write, that's why I said you should name the characters differently.
So I had R and then I used like a star, like a 5-pointed star versus a 6-pointed star.
Yeah, that's fine. As long as you're clear as to what is what. That's why I suggest making
I
a
define
different.
that.
Yeah. So if like G represents star, then if you write RG like this, then that star represents so that a star represents 0 or more G's in a row.
Okay.
Stars,
But
characters.
that RG is acceptable because R could be 0.
Yeah. So there's no operator between a regex, a valid regex, and then a character star. Yeah, because in the example I had 0, star, star, star.
Yeah.
Yeah, there's no operator in between each one of those because star actually is an operator. So.
Okay.
Other question? Yeah.
So, what we've covered, so what I've been told is that the next midterm is next week,
Next Wednesday.
next Wednesday.
Mhm.
So everything we cover up to when will be associated with it.
Same thing as last time. Everything whatever we cover next Monday.
Okay.
Yeah, which will be most likely the same thing that's in the schedule, most likely. But we'll see how far we get. It may actually be a little more, but it depends on how far we get.
Okay.
Other questions? Yeah. So for the next midterm, I'm planning on the same structure, but the last question, instead of 15 bonus points, I'm going to have 30. So it'll be out of 180 possible points, but 150 is a perfect score, I guess. So that's the plan.
What about the time limit?
Yeah. So and I'm going to make it 75 minutes like last time.
And the
Yeah.
bonus points are, they're not gonna get chopped out, they're gonna.
No. You carry everything forward. Everything. Yep. That'd be unfair. Other questions? But I'll talk about the midterm probably either Friday or Monday when we get there. Yeah.
And I just want to make sure our final will replace the midterm grade is better than our midterm.
Yeah. It individually replace. Yes. Yeah.
It is the final cumulative? Or?
Yes.
Yes.
Mhm.
Wait, individually replaces.
Yeah. So this is the most confusing thing I've ever heard for students. If you do better than midterm 1, it replaces midterm 1. Independently, if it better than midterm 2, it replaces midterm 2.
So it might replace both, or
It
no?
may replace both.
Oh, okay, well, that's good. We just need to-
Yeah, but don't count on it.
Well, yeah.
That's
Yeah.
assuming we take.
Yeah, don't count on it. Other questions?
Yeah, it's like
Can you go over a pumping lemma for CFL kind of problems?
Sure. What would be a good one? Okay. All right, so I'm gonna have this language. So it's almost like 0z, 1z, 2z, but now I'm including other strings where you may have more ones than zeros, as well as more twos than ones. So the number of each of the runs of 0, 1, 2 is not decreasing. It could stay the same or it could increase. Okay? And this is not context free. So if I want to prove it's not context free, what do? Assume L is a CFL. Then there exists a pumping length P for L. Then we got to pick a string with what two properties? In a language, in length at least P characters. Any example of that? 0 to the P, 1 to the P, 2 to the P. Is that in the language? Yeah, P is less than or equal to P, less than or equal to P. So, yep, but the proof will be slightly different here. Because it may be problematic if we just use the proof from before, which was pump up in every possible case, because if V, X, Y are either in the ones or the twos part, and I put more characters in, then I still didn't violate the J less than or equal to K condition, or the I less than or equal to J condition. But what could I do instead? Pump down. Okay. Well, let's see. If V and Y, no, that's fine. So what's an easy proof of this? Contain only ones or twos, then pump down. And why is that true? Because J and K, one of them is going to go down, and so therefore I'll violate either the I less than J condition, or the J less than K condition, or the I less than K condition. And yeah, and therefore I'll get out, yeah.
I guess the big question, what do you mean by pump down and pump up?
Yeah, so when we consider u v to the I x, y to the I z, this corresponds to setting I equal to 0. So remove a copy of v and y. So wherever v and y are, I take them out of this string. and then look at the resulting string. Whereas before, where we put an additional copy of each, now we're taking away the one copy.
Okay.
Yeah. Okay? Well, let's see. What if we had other cases? It may contain zeros. Could it contain zeros, ones, and twos? No. So what if Vy contains only zeros or ones? Well, if I pump down, then the less than condition may still be true, right? So what do? Pump up. So then pump up. I may get a string that's not even in the language because I may have a 1-0 substring or a 2-1 substring, but I don't even care about that. I care that I have either more zeros or more ones than twos, and therefore I get out. And those are the only conditions. And so therefore, in all cases, we leave L, and then therefore L is not a CFL. So this is just another example of you can have a different value of I for every decomposition. So based on the decomposition, we set I equals 0 in one of them and set I equals either 2 or larger in the other one. Okay? Does that make sense? Yeah. Yeah, I just said that. It just means pump down, remove a copy in V and Y. So just take them out of the string. Pump up means put an extra copy of them in. Well, it just means 0 copies of V and Y in the string. It just means looking at UXZ. It's the same thing as regular, the pumping limit for regular languages. But now we have 2 copies of things to pump instead of 1. Yeah.
Is this sufficient for an answer, or would we want to actually?
You should be a little more formal. So in terms of the correctness argument. So then, like for this one, the number of twos in, so let's call it S, the resulting string, is, let's see, is less than the number of zeros in W, or number of twos in S is less than the number of ones in S. And then in the second one, then the number of zeros in S is larger than the number of twos in S. Oh, this should be S. Or number of ones in S is larger than the number of twos.
So it's perfectly okay to just pick like variables and then just explain it that way without
If I say that S equals U V to the 0 X, Y to the 0 Z, then that's fine. Yeah. Then you'd have to say that S is not in L for obvious reasons. Okay. I think this example's in the book too. I don't have my copy yet, but yeah.
Can I take a picture of that? That's the last thing you said.
I'm uploading these later.
Okay.
Yeah.
So we only consider the ones and zeros and one. I guess we consider 0 and 2.
Because it can't contain zeros and twos because of this gap of P characters like before. Because if it had zeros and twos, it would have to span all the way across all those ones, but it can't. And so therefore, I don't need to consider that case. Yeah.
I have another silly question, but this time it's for 2.
Mhm.
Would we have to make, like when we do regex to an NFA, we have to make the little tiny NFAs for like each individual character. Would we have to make one of those for star and concat and union? Like would there be one that just, because I mean union is not an acceptable regular expression necessarily, but kind of curious how.
No, there's a difference between the union character and the union operator.
Yeah, so like the union input character.
Yeah,
in
that,
the library, that just has its own little.
yeah, that's just a little NFA.
Okay.
Yeah. That's why I say rename the characters and make your life easy.
Yeah.
But I did it formally that way because that's how regexes are normally presented anyway. So that's why. Other question?
Very helpful.
We've still got 20 minutes. I could just, yeah, well, let's keep going.
Can we do an example of converting from a regular expression to a NFA?
Okay, so let's do another example of regex to NFA. So, what?
I didn't say anything.
How about the regex for all valid regexes without subbrackets? No, I'm not doing that one.
Yeah, that's.
Let's see. 0, 2, union 1, 0, star. Okay. Well, could I make a regex for 0, 1, and 2 individually?
Yes.
Yeah, that's easy. So I'm just going to make a 0, 1 here, a 1, 1 here, and a 2, 1 here. How do I make a regex for 0, 2? Concatenate the the NFAs for those two regular expressions. So I'm going to put 0, 2 there. So 0's there. Oopsie. And 2's there. And then I connect them by making that state non-final and epsilon my way over. Actually, I'm going to put it in a different color.
Can we cheat on that in our homework, or do you want to see that too?
No, it says using the processes developed in class. But I do recommend making a black box NFA for a particular regex and then use that over and over.
Okay.
That's totally fine because the NFA is going to get pretty big. I think mine had, if I went through it, it was like 20 something states. So it wasn't small, but it wasn't ginormous. All right. Well, so we made one for 0, 2. Can I make one for 1, 0?
Yeah.
Yeah, it's almost exactly the same, but now we have a 1, 0 here. Okay, so that's pretty good. If I have a 0, 2 and a 1, 0, can I have one for the union? Yeah, how do I do it? Yeah, so make a new start state and epsilon my way over. So new color again. Actually, I'll do a different color for each one. So let's epsilon my way into the original, those guys. So this is 0, 2, union 1, 0. And then now once I have one for 0, 2, union 1, 0, could I get one for the star of that? Yeah, heck yeah. How do I do that? Yeah, make a new final start state. Then what do I do? Yeah. So I'm going to make a new final start state. Then, as the suggestion was, epsilon my way from the original final states. Oh, no, they are still final. So I'm not going to touch those. And then now what? Yeah, epsilon to the old start state. So this is star. Okay, does that help? Yeah. Yeah, so if you do use Blackbox NFAs, which I recommend you do, just make sure that you're absolutely clear that this is the NFA for the one that you built before. So put like a name on it as well as have the same number of final states, that sort of thing. Yeah.
What do you mean by black box?
Yeah, so if I have, so let's just say that this is the NFA R, let's say, for whatever it is. If I want to use R, I'm going to make a black box that has start state there, start state, the final states there, and then I can connect these up however I like. So then I'm going to call that R. Yeah, just, it doesn't literally have to be a black box, but using a diagram like this without having all the details is really helpful.
It's a little bit like when we're doing microprocessor with CSE120.
Yeah, yeah. So it's just an abstraction from what's really going on. Yeah.
How important is the correct number of start states?
The what?
How important is the correct number of start states in the black box?
There's always one start state.
Or I mean, final states.
It should be the same number as the original,
Okay.
as the one that you're using. But it shouldn't be very many if you're doing the method correctly.
Okay.
I never had more than like 3 or 4. So. Other questions? Yeah. All right. Yeah, sure.
In your money one.
What?
I just getting money for money.
Yeah. All right. So let's. So remember that the GNFA method works for DFAs and NFAs, but let's just work with the DFA over the alphabet A, B. I'm going to make Q2 final as well. Okay, so here's a DFA because it has a transition on A and B from every state. What do I do first? Yeah, so I need to make an initial GNFA. So initial GNFA. And the suggestion was, let's make a brand new start state. I'm going to call it QS. And how is QS can be hooked up? Epsilon transition in. And then what else? Exactly. So I'm going to make a brand new final state, QF, I'm going to call it, and epsilon my way from all old final states. A lot of people missed points on the midterm because they didn't include this initial GNFA. Yeah.
Even though we're ripping out the states, does it matter if we keep them final or not? The 2 original final states in this situation.
I guess technically no, because they're going away anyway.
Right.
But I would make the method the same. It wouldn't change anything. Even the correctness argument, it wouldn't change anything. But I would keep it, make them non-final. There's no difference though.
Okay.
Other questions? All right, so what am I gonna do now? I gotta start ripping states out. Any preference as to which state I rip out? Q0, okay, that's fine. So what I like doing is I like removing the actual state but keeping the transitions there so I remember what I need to do. So I'm gonna make this a different color. So what transition should I add to this GNFA? Yeah, QS to Q1 on what? A star B. Oops. No, I don't want that. So this one's got to go over here on A star B. And then now what? to Q1 on what? How do I get from 2 to 0? A. Loop on Q0 is A star. 0 to 1 is B. So what is the concatenation of those? A star, B. From 2 to 1. So A star, B. And remove this guy. Because there are 2 ways in and 1 way out, I make 2 transitions. All right. So I should call this rip Q0. Does it matter which order I do the ripping? No. All right, so now what do I do? Got to rip another state. Any preference? Q2. So I'm going to say, put this in a different color. So rip Q2. How many ways into Q2 are there from somewhere else? 1. How many ways out to somewhere else? Well, technically 3, but I should have in the original here, because I have 2 transitions, I should do a union over both of them. I should have done that. So this should be B union that. So there are actually 2 ways out. I should mean the number of states that you could go to from Q2. That's the correct answer, not the number of transitions. All right, 1 way in, 2 ways out. So what transitions am I going to add? Yeah, union to self loop, you're right, correct. So I'm going to have B was the original guy. So what am I going to add onto that? So union with what? Well, 1 to 2 is A. Any loop on 2? Nope, so ignore that. Then how do I get back to 1? Yeah, B union A star B. So then now I can delete that transition. Then what other transition? Q1 to QF, there's already a transition there, so I should do a union with what? Yeah, just a single A. Good. And then I can remove all this. Is there a state still to remove? Yeah, Q1's the only guy left, so we have no choice here. So now we have to rip that guy out. So I obviously will have a single transition left. All right, so what is the transition that I'm going to have from S to F? A star B. And then what? B union that guy. And then, oh, yeah, star. Thank you. Let's just make sure we didn't need that. All right, and then what? Epsilon union A. And I recommend putting parentheses every single time around them, just in case. So then I can delete all these transitions. And so what is the final regex? Yeah, that really long transition. So regex is this guy.
You could easily set that equal to R sub 1, for instance.
Yeah. Of course, yeah. So I can like set that to R1 and then use it.
Okay.
Yeah, of course. Because these get really messy. Yeah. Other questions? Yeah. DFA to regular grammar, fine. So let's use the same DFA. So I'm going to copy this guy down. All right, so here's the same DFA from before. If I want to make a regular grammar for it, what should I do? Well, what are the variables of the grammar going to be? The states. So I'm going to have Q0 is gonna have something that it produces. Q1 is gonna make stuff. Q2 is gonna make stuff. Well, what is Q0 going to make? AQ0 is one of them. What's another one? BQ1. What is Q1 gonna make? BQ1 or what? AQ2? Anything else? Epsilon. Good. Why epsilon there? It's the final state. Good. Because we want the opportunity of that variable dropping out. Q2, what does it make? BQ1 and what else? AQ0 and epsilon. Good.
So then the right side and the rules are going to be a combination of input symbol and the
Yep.
state that it goes to?
As well as epsilon if it's a final state. But if I had, say, another transition here on epsilon, then I need to include or Q0 directly. Because it may be an NFA. But it was nicer here because it was a DFA. Any questions about that? Other questions? Unless he has a different question.
I have a different question. It's short.
Oh, well, okay, short question.
If I were to concatenate a black box for something with a star on it, would I remove the start transition or the final transition that was put in the front, since it's going to be concatenated and have to go through?
Well, no, you remove what states are final, and then epsilon from all old final states. You don't remove any transition.
So it doesn't be. Well, I didn't mean remove. I just meant make it non-final.
Yeah. You always make in concatenation. You make the first guy's final states no longer final, and epsilon from all those over.
Okay.
Yeah, always.
Sorry, at the end of Q2, the concatenated Q0, is that part of the solution, or is that just?
No, if I put an epsilon transition there, I'll actually put that in a different color, just to
Sorry, I just looked it up.
like that. All right, so it was asked to do the other way around. Let's do it from this grammar. All right, so what are the states going to be of whatever I'm going to make? The variables, which are Q0, Q1, Q2, but what else is there? A brand new final state, because we needed that extra final state. All right, so what is the start state going to be? Q0, assuming that the grammar was the same. All right, what are the transitions going to be? The self loop on A, Q0 to Q1 on B. Q1 does a self loop on B. Q1 goes to Q2 on A. Q1 on epsilon, what does that do? Goes to the final state on that thing. What if instead, or in addition, I have a single terminal with Q1? Yeah, it's going to go to QF on that symbol. Okay? So let's go back. Q2 goes to Q1 on B, goes to Q0 on A, and then epsilon is its way over to QF like before, and in red it goes to Q0 on epsilon. Okay, so it's almost exactly the same process but reversed, but we need that extra final state because we need a way for the variable to disappear. So, other questions? We got like 1.5 minutes. Yeah. No, because it always produces an NFA because the final state has no outgoing transitions. Yeah. But can we convert it to a DFA? Yep. So. Cool. Other questions, last minute questions? Got like 15 seconds. I'm precise on time, so. Should be, yeah.
I put a lot of thought into ask
Yeah.
a quick question.
Yeah.
Say I have a dead state,
Mhm.
and making a regex, and when I rip that,
Yeah, it'll do nothing.
so I just delete that.
Yeah. Mhm. Yeah. Other questions? Cool. See you guys on Wednesday.